Welcome to another walkthrough. This is an Edexcel AS level math paper 2024 Pure 1. This is for the year 12 students in the UK. Now this time I'm going to be doing the paper unseen. That means I've never seen it before, so I'm going to be timing myself as well, and I'm going to use the exam condition of 2 hours here. So as you can see, there is a timer on the bottom left of the screen. I'm going to start the timer now. Okay, here we go. Gonna do it here. So question 1. Okay, let me just move. Okay, question 1, we have to integrate that. Okay, so well, the easiest way to integrate an expression like this is to probably split. Yeah, so I'm gonna be splitting the terms. Okay, like that. And x square root x is basically x to the power of a half. So when you divide by x squared, you just subtract the power. So it's actually x to the power of half minus 2. So that's minus 3 over 2, right? And then the other one is just 3x to the power of minus 2. Okay, usually we do it this way so that we don't get confused in terms of the sign and the power. Okay, and we integrate. So the power added by 1 and bring the power down to divide. Minus 3 over 2 plus 1 is minus 1 over 2. Yeah, so we put that first. Minus 1 over 2, so we have to divide by the minus 1 over 2. That is the same as multiplying by minus 2. So I get a minus 4 here. Yeah, basically. Okay. And then the other one, the power become minus 1. So dividing by minus 1 becomes a plus here. And then x to the power of minus 1. And then we plus c. Well, if we want a simplest form, then we can do minus 4 over square root x plus 3 over x plus c. Well, that would be it for me. Okay? On to question 2. Question 2. We are given the expression with the function that, and then where a and b are constant, given that x minus 4 is a factor of fx. So this is factor theorem then. Okay, so the factor theorem says if we have a linear factor, x minus 4, we can just substitute the critical value. The critical value in this case is 4, so I'm just going to sub 4 in, so we can write f4 like that. It's going to be equal to 2 times 4 to the power of 3, just look at the expression there, times 3a, now we don't know what a is, times 4b plus 8a. Yeah? Okay, so let me check again if I substitute everything correctly. Yes, I did. So 4 to the 3 is 64. 64 times 2 is 128. 3 times 16 there, 4 to the 2 is 16, is 48a plus 4b plus 8a. Wrapping up everything, we get, what do we want here? Okay. And we're going to equate that to 0, of course, because factor theorem says we have a remainder of 0 there. Okay, so it's minus 40a on the right, and then plus 4b, and then plus 120. Which means that we can probably divide everything across by 4. Okay, so we get 0 equals minus 10a plus 4b plus 32. And then rearranging to just get the, oh, I forgot that this is gone also. So we should get 10a equals 32 plus b as required because they want that. Now for part B, okay, now also given that x minus 2 is also a factor, express fx in the form. We know for sure that there is an x minus 4 and x minus 2 in, and the other one we just, work it out. So how about we do this first? So we can do it a number of ways. We can also just, get another equation. Let's get another equation, right? So f2 equals 2 times 2 to the 3 using the original expression, 3a times 2 to the 2 plus b times 2 plus 8a again. And then we put that to 0 again. So 2 times 8 is 16 minus 12a, just multiplying out there, plus 2b plus 8a. Okay, So we move the 12a on the other side. We're going to get, oh, hang on, it's not 12a. We also have the 8a there, so it's 4a here, equals 16 plus 2b, right? So that's another equation. So when we solve for the other equation here, we can get the a and the b, and then we can, find the other factor there, okay? So, yeah, I guess. Okay, so here we need to solve simultaneously. So the way I would do it is to bring this equation down, and then let's multiply that by 2. So we get 20a equals, multiply by 2 here, 64 plus 2b. And I would like to maybe subtract one from another. It's fine. Negative 16a equals, that would be minus 48, right? And the 2b's are gone. Yeah? So now I get a equals 3, just dividing that by minus 16. If a equals 3, then b equals, which one should we use? So I'm going to use this one still. Just 10 times 3 minus 32, just rearranging that. So we get minus 2 there. Okay, so b is minus 2. Okay, now a is 3, b is minus 2. Just bear that in mind. So we have fx equals, a is 3, right? So that's 9x squared, just looking at the original expression again. Plus b is minus 2, right? So that would become minus 2x plus, and then a is 3, so that should be 24. Okay, so we already know that there are already two factors, x minus 4 and x minus 2. Okay, well, seems like there need to be a 2 here because I mean, the coefficients of two x's here are just 1. So the only way to make this make sense is to have 2x, because then when you multiply all the front term here, they would become 2x cubed. And then let's say we don't know this. Let's make it a plus k. But we know that the last term here is 24, right? So that is multiply minus 4 multiply minus 2 should give us 24. Okay, so k is just 3 if you divide everything by minus 4 and minus 2. Yeah? So that means fx is therefore 2x plus 3 instead of just having a k there. Okay, that's it. So that's our answer for part B. Now part C. Hence state the number of real roots in the equation fx equals 0. Well guys, this is degree 3, and because we can already factorize this into 3 brackets, and there is no other limitations or conditions here about the roots of x, so the real roots here should just be 3, right? 3 real roots, because we get 3 brackets. So the answer to this is minus 3 over 2, this is 4, this is 2, okay? Alright, so that's part I, that's II then. Write down the largest root of the equation f a third of x equals 0. Well guys, if we think about the graph here, yeah, well, you should already know how to plot the cubic function here, right? So the cubic function, when you have 3 brackets, you can just do, so let's say 2 is here, 4 is here, and minus 3 over 2 is there. This is a positive cubic, so it's going to look something like this, right? Now, this is fx, right? Now, what happens when you have x a third of x? Well, you are actually not shrinking, but stretching along the x-axis. You're stretching along the x-axis, that means this will be multiplied by 3, this will be multiplied by 3, and this will be multiplied by 3. So everything along the x-axis will be stretched, right? So it's going to look something like this, and going up to the right. So the 2 will become the 4, the minus 3 over 2 will become the minus 9 over 2. Sorry, the 2 will become the 6. Hang on, it's multiplying 3, right? Okay, so if I want to draw this out, so the minus 3 over 2 will become minus 9 over 2, so I'm guessing that the y-intercept should be the same point, and that should be a minus 6, and then it's very stretched to the right like that. So this will be a 6, this will be a minus 9 over 2, yeah, multiplying by 3, and the other part here where it cuts the x-axis will be a 12 because you multiply that by 3. Alright, so just drawing that out, it looks like that. So the largest root of this in terms of x here is going to be 12. Right, so largest is 12 then, largest root. Alright, I just answered there. 12 is the answer. Okay, next question, number 3. Relative to fixed origin O, point P has the position vector 9i minus 8j, point Q has a position vector that, find PQ. Okay, so this is a relative vector PQ. We can find that by doing OQ, which is the position vector of Q, minus OP, which is the position vector of P. Now I would like to do this by using a column vector because I prefer that. So 3 minus 5 minus OP is 9 minus 8, yeah? So putting an I on top, the J at the bottom. Let me check the numbers. Okay, so it's going to be minus 6i, because 3 minus 9, and then minus 5 minus minus 8, that's minus 5 plus 8. So that's a plus 3j. All right, I'm happy with that. So that's the position, the relative vector PQ. Okay, and that's part A. So part B. Given that R is the point such that QR is that vector, show that the angle PQR is 90 degrees. Okay, so we already have PQ. Let's say PQ looks like that. Okay. And then we're going to prove that R is a point where PQR, well, let's say I is around here, so PQR is 90 degrees, yeah? That. We already know QR here is given to be 9 and 18 as a column vector like that. And then we already also know PQ, right? We already found PQ, so that's minus 6 and 3, right? So we have two vectors here. We need to know whether they are perpendicular. All right, so, well, I don't think you've ever done a dot product, so I'm not going to go with that. So the way we do this is probably proving that it is a right angle triangle, right? So we're going to prove that by, assuming it is a Pythagoras triangle or right angle triangle first. So we can find the distance there, can we not? Well, we can find PR, right? Because we are given that QR is 918. So if we find PR first, so PR would be PQ plus QR, right? And that would be minus 6, 3, plus QR is just 918. And that is 3i plus 21j, like that. So if we find the length of these three sides, assuming it's a right angle triangle, and if it works, then it should be a 90 degrees, right? So, well, we can do PQ, yeah, PQ squared. I'm just going to do squared like that. PQ squared is just 6 squared plus 3 squared equals, so that's, we don't need the square root there because we're going to do the square first. 6 squared plus 3 squared. 36 plus 9 is 45. Yep. And then the QR squared is 9 squared plus 18 squared. I'm just taking the components and square them and add them up. So that's 81. Oh, I need a calculator. 9 squared plus 18 squared. That's 405. Okay, if we add them up, it's going to be equal to, well, add them up in square root maybe. Well, hang on, we probably need another one, which is PR. Let's do PR already here. So PR is 3 squared plus 21 squared, which is, that's 441 plus 9, right? So that's 450. Okay, so we can prove here that PQ squared plus QR squared equals 45 plus 405 equals 450, and then it's equal PR squared, right? So that's Pythagoras there. That means triangle PQR is a right triangle. Therefore, PQR, the angle PQR right there, is 90 degrees as required. Okay, we have proved it. Okay, that's part B done. Part C, what time do I have? Okay, yeah, we have almost 2 hours here. C, given also that S is the point such that PS is 3 times QR. Okay, so we had P and Q and R here, right? And this is perpendicular. PS is 3 times QR. Well, they're right like that. That means they're parallel. PS is parallel to QR. Okay? But PS is 3 times QR, so I'm going to move it a bit down and just, visualize it like this. So that should be our S right there. About 3 times QR, okay? Parallel. So they have to be parallel because writing the vector form like that means that they are parallel. Now we find the exact length, exact area of PQRS. All right. So if we draw this line, that looks like a trapezium indeed. So trapezium means that we just have to find this length and these lengths and use the 1/2 times height times the sum of parallel sides. Okay? All right. So I think we already know most of them, like QR and PQ. So I'm just going to look here. QR is root 405, right? Yeah. And then PQ is root 45. Okay. And then, well, because SP is 3 times, right, QR, so the length is going to be 3 times QR as well. So we have that. Yeah. So now we do the thing. So area of PQRS would be 1/2 times the height, which is root 45, is the PQ there, times the sum of parallel sides, which is this. Okay, just that. So we want the exact area, so we need to deal with the square roots and everything there. So 45 is 9 times 5 in the square root, so we can pull 9 out as 3, like that. Well, if you simplify the brackets there, you get 4 of those, of the square root, 405. And 405, so I'm just doing 4 here because we have 4 of them. So 405, what do we have? 405, we have 5 times 81. So that is 9 root 5, right? Yeah. So wrapping up, I'm just simplifying. So 2 times 3, which is 6. 6 times 9. 6 times 9 is 54. 54 times 5, 120. No, 170. Is it? Yeah, 270. Okay, so that's the answer, I believe. Yep, I'm just mental mathing there. Okay, so that is part C done. We should be happy with that. Next question 4. Ooh, that's a big question. No, it's just a big diagram. For part A. Okay, 19 minutes now. Figure 1 shows a sketch of a triangle ABD and triangle BCD. All right, so we have that sketch there. ADC is a straight line. Yeah, I'm just following the question here. ADC is straight line. BD is x plus 3. BC is x. Angle BDC is 30. BCD is 140. Show that x is 10.5. Correct the 3 significant figures. So x is part of the length. The 3 lengths there. Let's see. Okay. I think we can use sine rule on the triangle BCD, yeah? So triangle BCD, we use sine rule. All right. So we take this opposite side, x plus 3 divided by the sine of the opposite angle, yeah, equals x, which is opposite to sine 30, right? Yeah. Okay, so that's the equation we need to solve. And we don't have to find the exact value, so we are okay with using a calculator here. So I just know that sine 30 is 1/2, so it's 0.5x here plus 1/2 times 3 is 1.5. I'm just going to do in decimal then. And then this is sine 140 times x. Just cross multiplying there. So if you do the algebra here, making x the subject, you would get 1.5 all divided by, yeah. So I move 0.5x to subtract the other side first, and then factorize x out, and then divide. So that's going to be minus 0.5 here. Okay? If you're not happy with this, you just try stop the video and just work through by yourself. But I'm thinking I should just use a calculator there. Okay, so 1.5 divided by sine. We need to make sure that it's in degree here. Wait, let's sine 30. Wait, yeah, that's degree. Okay, yeah, never be careless about units, guys. Okay, so sine 140 minus 0.5. Okay, so that's about 10.505 dot 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 equals 10.5. 3 significant figures. Yeah, as required. Okay. And then part B. Given also that A equals x minus 2, AD. Well, that's already known. Find the length of AB, giving your answer to 3 significant figures. So AB. Okay. That looks like we need to use the cosine rule on the larger triangle. So larger triangle ADB here. Cosine rule. Okay, so cosine rule, I'm just going to look at the AB side, which is the one we want, as the longest side, the hypotenuse side. So that's AB equals square root. Yeah, cosine rule, we have a square on both sides, but then if you want AB, you can square root. The two sides square, so that's x minus 2 squared plus x plus 3 squared. So those are the two sides. I'm just putting x in here first so that you guys can catch up. And then minus 2 times a times b, right? That's the formula for the cosine rule. And then times the cos of the angle between the two smaller sides. So it's cos of 180 minus 30, because that's adjacent to 30 degrees. So that's cos 150, right? Okay, because we are given that ADC is a straight line. Now, I'm just going to put my answer first, and then, so what I'm going to do, because I don't want to keep writing that long decimal all the time. So that was, wait, hang on, that was not the answer. Oh, what was it now? 1.5 divided by sine 140 minus 1.5. Sorry, 0.5. Okay, I'm going to put that as an answer first, and then clear. So it's a square root of answer. Oh, that's horrible. Okay, I need to pull back my calculator. Sorry, guys. Calculator. No, that's not. Okay, I'm confused with my app now. Okay, here we go. What? No. Oh, come on. Okay, that should work. So, brackets answer, that's the answer, minus 2 squared, and then plus, answer again, plus 3 squared, yeah, 2 terms already, minus 2 times answer times, oh, hang on, no, not answer, 2 times answer minus 2, wait, what? No, that's horrible. Oh, no. Yeah, I kind of have a trouble with the calculator time to time. That's not good. Okay, I'm gonna start over because I already lost the information there. Okay, so put that as an answer first. Clear. So that was square root. What was it again? I'm just gonna look at the question here. Answer minus 2 squared plus answer plus 3 squared minus 2 times, again, answer minus 2 brackets times open bracket, answer plus 3 close bracket, and then don't forget the cos times cos of 150. Bam. Oh, it's taking some time there. Okay, so it's 21.29959. So that's going to be 21 point, what was it again? 0.3 then. There, right? Okay. Let me check if I put everything in fine. Yeah, I hope so. 22 makes sense. 21 makes sense because x is about 10. That should be longer. Well, it may not be, but the figure is probably not to scale, I hope. Right? You know what? Let me check again because that doesn't feel... Oh, and I lost everything. Okay. I think I'm gonna change that to 10.505. Yeah, let's do that. Let's do that. Okay. Let's see. So that minus 2 times 10.505. That's taking some time. Okay. I don't know why a calculator can take that long to just give me that value. Wait, what? A calculation timeout. Am I doomed here? Hang on. 10.505 plus 3. What's the problem with that? Cos 150. There doesn't seem to be any problem there. Okay, 20. Yeah, okay. Yeah, that's right. Let's go to the next question, number 5. Sorry. The curve C1 has equation that looks like a hyperbolic curve. Sketch C1 stating the coordinates of any points where the curve cuts the coordinate axes. Okay, so A, I, sketch, C1. So this would be the hyperbolic curve with y equals probably 6 over x. Doesn't matter where 6 is 1 or something else. It's just steeper. Yeah. But we plus 3. So at first we have the x asymptote and y asymptote as these two. If you are adding 3, so it's going to be moved up, right? So everything will be moved up like that. And the asymptote instead will be at y equals 3. Yeah. So we have to state the equation of the asymptotes. So let's wrap everything into part A here because it's in the same curve. And then another one is x equals 0 as the asymptotes. And then we need to give the coordinates of the points that it cuts the coordinate axis. So it doesn't cut anywhere here, right? Because it's going up that, but it cuts here. Okay, so and that is where y equals 0. So we're going to put y equals 0 equals 6 over x plus 3, and that gives x of minus 2, right? Yeah. So this is minus 2, 0. Okay, so that's the coordinates of the x-intercept. Now part B. The C2 has equation that also, that's a quadratic or parabola. C1 and C2 intersect when that. So we need to show. So we need to show if we try to solve simultaneously, we're going to get something like that. So we just equate y1 equals y2. Yeah. So y1 is just 6 over x plus 3 equals y2 is 3x squared minus 4x minus 10. Well, how about multiplying out by x, right? So we get 6 plus 3x equals 3x cubed minus 4x squared minus 10x. Yeah, just multiplying out by x. And then we rearrange to make one side 0. I'm going to move to the left here. X squared. So minus 10x minus 3x becomes minus 13x. And then minus 6 because we move it to the other side, but right on the left side. And that is as required. All right. Given that the x-coordinate of one of the points of the intersection is minus 2/3. Okay. Yeah. Use algebra to find the x-coordinate of the other points of the intersection between C1 and C2. So we already know that minus 2 over 3 is one of the roots. Yeah. Because it's the solution to this. The minus 2/3 is the solution to this. So we can use that to find other roots. The way I would do this is to maybe use that root there and factorize it, right? So I would, or maybe I would do long division. Yeah. So this is how I would do it. Long division. And then we use, so minus 2 over 3 as a root would mean that the linear factor would be 3x plus 2. Yeah? Because if you put that to 0, the critical value is minus 2 over 3. Right? And that makes sense because we have a 3x here because there is a 3 in the x cubed term. Right? So I'm going to be dividing that polynomial function by this factor. I mean, you can also do a calculator work, but you have to show the working anyway, because they say solutions relying on calculator technology are not acceptable. Okay, yeah, we need to show some work here. All right, so I'm going to be dividing that. So dividing just the first term with the first term, we have x squared. Yeah, you can try that. 3x cubed plus 2x squared. Just multiplying back, right? Multiplying that to that gives this. Multiplying that to that gives this. Okay, and then we subtract, right? Subtract these two lines. So minus 4 minus 2 is minus 6x squared. We pull the next term down. Okay, and then we again dividing the first term into the first term. So 3x dividing into minus 6x squared, we get minus 2x, right? Minus 2x. So again, the first term the same, that's the point. And then the second term, minus 2x times 2 is minus 4x. Subtracting these, we get minus 13 minus minus 4, so that would be minus 9x. Pulling minus 6 down again. We are expecting to have 0 remainder here, okay? So minus 3x dividing into minus 9x, we get minus 3. And that is minus 3x minus 6. So remainder is 0 indeed. So we can we can say now that this is the quadratic factor of the thing there, the equation there. But we can also do further, because we can factorize this to be x minus 3 and x plus 1. If you have practiced enough quadratic factorization, that should be straightforward. So we can pretty much say that can then be factorized as x minus 3, x plus 1, and the thing we just used to divide in the first place. Well, so the other 2 points would just be minus 1 and 3. These are the other points of intersection between C1 and C2, and we are done. We don't need to find them. We don't need to find the y, just x coordinates. All right, I'm done here for C. And also question 5. Next, question number 6. All right. The binomial expansion of that up to and including the term x squared is that, where a and b are constant, show that a equals minus 5 over 8. So we're just going to expand the thing, right, using the binomial coefficient. So, well, just writing down first. That's part A. Okay, so it's just the first term to the power of n, which is 12 there, plus the second term, which is 12c1 here, right? And 1 to the power of 12 minus 1 times ax to the power of 1. So I'm using the binomial expansion formula here. And when you keep going, the first term will have a power by 1 less, and the second term will have power by 1 more. So if we expand to the third term, it's going to be 12, 2 like this, and 1 to the power of 12 minus 2, and then ax to the power of 2. Yeah? So this is 1 plus 12c1 is 12. 1 to the power of anything is 1. So that's 12 times ax, so 12a times x. Yeah? And then the last term, just wrapping up here, so 12c2, I believe it is 66. Is it? Let me just make sure. 12c2. Yep. Okay. And then this is a squared, x squared. Okay? That's it. So we need to show that it is a equals minus 5 over 8. Well, we know that they've given us that minus 15 over 2x is the same as 12ax. So we can equate the equation there like that and solve. So a is, well, if I use 3 to cut here, I get that. So if we solve for a, we would get, minus 5 over 8 as required. All right, so that's part A done. Part B, hence find the value of k. Well, yeah, so the third term, k is equal to the coefficient of x squared, which is 66a, which is 5 minus 5 over 8 squared, right there. That's easy peasy. Okay, so 66 times 5 over 8 squared like that. Yeah. So that's, I'm just going to use an exact form, 825 over 32, like that. Yeah. Okay, so that's the value of k. Using the expansion and making your method clear, C, find an estimate for the value of that. Okay. Okay, so part C down here. Well, this is where you need to equate between the binomial expansion and the exact form, right? Okay, so we are gonna make the estimate. No, sorry, forget that. We're gonna make the estimation for 7 over 16 to the power of 12. Well, if you look at 7 over 16 here, and 1 plus ax over 12 here, yeah, to the power of 12. It's like, it's as if we can find the x value, yeah, we just find the x value from this, right? We're going to use our expansion, which is up to the x squared term, yeah, but we need to find what x is first. So you equate this and you find out what x is, because we are seeing that this term is equivalent to that term because they are both to the power of 12. Okay, so that means 1 plus a was minus 5 over 8, right? So I do that, solving for x first. So x would be what? Subtracting 1, I get 1 over 16. So 1 over 16 divide, multiply by minus 8 over 5, right? Just moving x there. So that means x would be minus 1 over 10, right? Yeah, I'm happy with that. So x is minus 1 over 10 right there. Yeah. Wait, hang on. Yeah, I think I'm happy with that. Okay, so x is minus 1 over 10, and then we're going to use this x value, substitute into this to get the approximation. Okay, so that right there would then be approximate as 1 minus 15 over 2. X is minus 1 over 10. Just substitute x into your expansion there. K was that, so we're going to have to follow through using that k value, and then x squared. Yeah, so whatever that is, it would be our estimate. All right, 1 minus, what was that? So that's a plus 15 over 20. Just calculating that all. Yep. Oops, don't do that again. 15 over 20, and then plus, yeah, plus 825 divided by 32. And then that would be 100, right? Times 100 there, because, oh, sorry. Because that's 1 over 10 squared, and the minus goes away. 4 decimal places, so that's 2.0078, 4 decimal places. Yeah, I'm happy with that. Okay, let's move on to question 7. We are at 42 minutes. Okay. A chimney emits smoke particles. On a particular day, the concentration of smoke particles in the air emitted by this chimney, p parts per million, is measured at various distances, x kilometers from the chimney. Figure 2 shows a sketch of a linear relationship between log 10p and x that is used to model this situation. So we have a log here. The line passes through 0, 3.3, and 0.6, 2.1. Find the complete equation for the model in the form that. Okay, so we have a linear equation. That means if we plug y equals mx plus c, yeah, or better yet, we can do y minus y1 equals mx minus x1. So that's my part A there. Okay, so y, in this case, the y-axis is the log base 10 of p. Okay, y1, let's pick 3.3. Okay, m would be the gradient between the two lines, and bearing in mind that this is a negative gradient, so I'm just going to do the gradient here. So that's 3.3 minus 2.1 divided by minus 6, or divided by 6, but I put a negative in front here. Okay. All right. Yeah, I'm happy with that. And then multiplied by x, which is just x in this case. Yeah. Minus x1, we pick 3.3, so this one got to be 0 here. If we simplify all that, we rearrange p to be the subject, then we should get the equation in A. All right. So that's log 10p equals, just multiply that out. So 3.3 minus 2.1, we get 1.2. 1.2 divided by 6 is 0.2, so it's minus 0.2x. All right. Yep. And then okay, so let me think a bit. Oh, I forgot the 3.3 right here. Okay. And then if we make p the subject right here, it's going to be 10 to the minus 0.2x plus 3.3. Well, we can use the law of indices here, where a to the power of m plus n, we know that we can split them to 2 powers like that, multiplying. Okay, so I'm just going to keep the law here and show you guys that this is also written as 10 to the power of minus 0.2x times 10 to the 3.3, right? And then a would be the 10 to the 3.3, and b would be, okay, wrapping up a bit, I'm just going to delete that now. So 10 to the 3.3 is, okay, so a and b are constant, give a and b each to 4 significant figures. So 10 to the 3.3 is, oh, sorry, what's that? Okay, 1995. All right. I really have a problem with this. 1995, and then we need to do, hang on, let me just do this first. So that's 10 to the 3.3, and 10 to the minus 2, minus 0.2 would be 10 to the minus 0.2, yeah, would be 0.630957 ... Okay, so that we can write p, 1995, yeah, times, well, if you look at this, yeah, you can look at this as 10 to the power of minus 0.2 and then brackets to the power of x. So that would become our a there. All right. So what was it again? A is then 0.630. That's 10, because that is for this 4 significant figures to the power of x, right? So that's it. Yeah, that's done. B, with reference to the model, interpret the value of a times b. Okay, so the value of a times b in my, thought process here comes from the fact when x equals 1. So if you put x equals 1, you get ab. Okay, so b, that is, so p equals ab, right, when x equals 1, yeah? If you sub x equals 1, it's just a times b. So that is telling you it's the value of what? P is the chimney parts, it's the concentration of smoke particles emitted by the chimney, parts per million, measured at 1 kilometer from the chimney. Yeah? So that is the answer, actually. Okay, you just have to know how to interpret that and include the context of the thing. So AB is the concentration of smoke particles in the air. I'm writing everything. Emitted by the chimney in ppm, measured at 1 kilometer from it. Yeah, because that's when x equals 1. Okay, so next, question number 8. Ooh, we get some graphs here. Okay, in this question, you must show all stages of your working. Solution relying on entirely calculated technology not acceptable. All right. Well, back in the days, they didn't need to write that like every time, because our calculator was kind of like not that good. It couldn't even do quadratic solving actually. All right. Anyway, number 8. Show using calculus that the x-coordinate of A is 2. Well, okay, so what have we here? The line L, which is the one in the plot there, is the tangent to the curve at point A. Okay, okay. All right. Given that line L has that equation, so the m of tangent is minus 2 from that line equation, minus 2x plus 7 there. We know that that is the point of tangent, so the gradient must be the same. That means we need to differentiate the y first. Yeah, so we get 3x squared minus 14. Just do the differentiation in your mind, you will get that. Yeah, okay. Can you give me 1 second? I need to close the door. It's kind of rainy in my country right now, and just the dog keeps barking in my neighborhood. Anyway, yeah, that's the derivative of y, okay? And we need to equate this to minus 2 because that's where they tangent. So we are solving this. We get x equals minus 2 plus 14 divided by 3 square root. And that is when we need a positive value for that. So that is root 4, that is 2. Okay, so A is 2 there. So that is shown as required for part A. Part B. The line L cuts C again at point B. Verify that x-coordinate of B is minus 4. Verify? Verify, right? Well, to verify, we need to sub x minus 4 into the two functions. Yeah, so this is not determine or show. It's to verify. Verify means you inspect, if it makes sense. So we're going to put minus 4 to the curve equation there. Yeah, so that gives minus 4 to the power of 3. That's plus 14 times 4 plus 23. I'm going to note that down. Y from the curve. Is it the same as y from the line? So y from the line is y equals minus 2 times minus 4 plus 7, which is 8 plus 7, which is 14. Yeah? So they both give the same y values. So x equals minus 4 gives y equals 15. The valid intersection. Yeah? So x of b is indeed minus 4. That's how you verify. And I'm guessing there's a part C down here. Okay, part C. The finite region R, shown shaded in figure 3, is bounded by the curve C and line L. Using algebraic integration, show that the area of R is 108. So this is where we find the area in between two functions that have the same kind of like the x value there. So if you look at the curve here, I'm just going to draw quickly. Like that. This is the x-axis. And this is the y-axis. Okay, so the point A and B right here, they have the same, if you look at the two lines, the curve and the line, they have the same left and right bounds, right? When this happens, you look at the graph above and below. We can do the area in between, right? That's the area in between the two lines. So R equals integral of the y function of the top one minus the y function of the bottom one, right? Dx, of course. And, the bounds here would be from x of b to x of a. X of b was minus 4, x of a was 2, right? Yeah. So so that would be integral minus 4 to 2 of the top function. The one above is the curve. So that's x to the power of 3 minus 14x plus 25 minus the function below. So that's the line, so which is minus 2x plus 7. And then we do dx here. Okay, and put the bounds from minus 4 to 2. And that's going to give us 108. Let's do the math here. Okay, so I'm just going to simplify everything first. So that's x cubed minus 14x plus 2x will be minus 12x, right? There's no x squared here. And then 23 minus 7 would be plus 16. Yeah, I'm happy with that. Integrating. And then we get x to the 4 over 4. Hang on. Okay, integrating 12x, we get x squared divided by 2, so that should be 6x to the 2. Yep, plus 16x. Okay, and this is from minus 2 to 4. If you guys have seen some of my videos, you will know that I prefer doing the bounds differently from other people. So the way I do it is I do it separately by term. So I put over 4 for the first term. So I'm doing the first term first. And then I do 2 to the 4 minus 4 to the 4. That's done for the first term. The second term I put 6 out. And then I do 2 squared minus 4 squared. Yeah? And that's going to happen for all the terms. You're going to write less using this method. That's why I prefer this method. And it's less confusing for the sign, about the sign for me. 2 minus 4. Yeah? Just that. So if we work that out, we should get the answer as 108, hopefully. Yeah, we can use calculator for that, you know. So 1 over 4, and then times, let's move there first. 6 to the 2 to the 4 is 16, minus 4 to the 4, whatever that is, I don't know. Okay. Yeah. Minus 6 times, so what is that? 4 minus 16. Yeah? Plus 16 times 6. There you go, 108, right? Okay, so that's done. That's done for number 8. Now we're on to number 9. Logs again, yeah? Number 9. We have, we are at 57 minutes. I think we have time. P equals log A of 16, Q equals log A of 25, where A is a constant. Find in terms of P and Q, log A of 250. So, part A, well, log A of 256 is basically log A of 16 squared. Yeah, let me check if I'm right. 16 squared, yeah, 256. That means it is 2 log base A of 16. And we already know that that is going to be 2p for the first one, because log A of 16 is p. Yeah, so you use the log property to put 2 in the front here. Part B, log A of 100. Well, tricky. So log A of 100 is basically log A of 10 to the power of 2, which is 2 times log base A of 10. Now log base A of 10 is basically log base A of 5 times 2, right? I'm just going to write here first. Okay, so that's going to be, I'm going to keep it as this first. So yeah, let's come back to that later, but we need to maybe simplify P and Q first. Let's see. Or, hang on. Let me try something. If we multiply P and Q, what happens? So if we multiply P and Q, if we add P and Q, the 16 and the 25 will multiply, so that we get 400. Okay, let's try to do that first. So if we plus P and Q like that, we're going to have that, right? Again, guys, this is unseen, so I'm doing it live. Okay, what was it again? 400. So we're going to have log base A of 400 here. Okay. What is that then? But we have log A of 100 to be B. So how can we put that in? Okay, so this is going to be log base A of 100 times 4. So P plus Q is that, which is log base A of 100 plus log base A of 4. That's probably not what we want there. Oh, but log base A of 4, okay, because, well, P is log base A of 16, which is log base A of 4 to the 2. So it's 2 log base A of 4, right? That's P. So that means this guy is P over 2. You just look at this one here. That guy is P over 2, right? So we're just going to keep this small into one corner because it's like our, yeah. So that is log base A 100 plus P over 2 as discussed earlier. That's P plus Q. So we now need what we now see what we want here. Log base A of 100 then equals, if you rearrange that, make this thing the subject, you get P plus Q minus P over 2, which is P over 2 plus Q. So that's the answer there. Okay, so that's part B. Part C. Ooh, okay. So, okay, I'm going to make it to log 16 now because, ooh, okay. This one right here. So, part C, log base A of 16 times 5 would be 80. And then here we have multiply. Ooh, log base A of 3.2. So, 3.2 is 16 times 0.2, isn't it? Okay. So we have log base A of 16 plus log base A of 5 times log base A of 16 plus log base A of 0.2. Okay, so we have the P in the picture there already, but the log base A of 5 here, again, for the Q, right, is also log base A. Log base A of 25 is the same as 2 log base A of 5 if you use a log property again. So that means log base A of 5 is just Q over 2, right? So anywhere we see log base A of 5, we can just put Q over 2 in there, right? But what about this? Well, this is 1 over 5, isn't it? So this will be log base A of 5 to the minus 1, which is minus log base A of 5, because you can pull the minus 1 in front. So I would have P plus, this will be Q over 2, as mentioned. That's P again, plus or minus Q over 2 again, right? That's Q. Okay? Yeah, this is not easy actually. You're gonna have to have a good foundation of log properties. So yeah, the log base A of 5 is Q over 2, but minus would be minus Q over 2. And this is difference of squares, so P squared minus Q to the power of 2 to the 4 if you multiply them all out. And that is the answer there. Okay? Yeah. All right, on to question 10. Figure 4 shows a sketch of the circle C. The point P, blah, 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 is the center. The point Q is on the line L. K is a positive constant. Okay. Line L is the tangent to C at Q. Given that the gradient of L is minus 2, okay, show that blah, blah, blah. All right. Okay, so I mean, this is very classic for circle equation. When you have a circle and a tangent, and when you know that this is, when somehow it's given you that this is the gradient of the line, let's say we should find the gradient of the line called the tangent here, and this is the gradient of the normal, right? Because they have to be perpendicular here according to the circle theorem, where you draw a line from the center of the circle to the tangent, it's going to be perpendicular, right? So, okay, so if you know the gradient of the tangent being -2, that means the gradient of the normal there, which is the radius line, is 1/2, right? Yeah, they have to multiply to get -1. Well, but this happens to be the gradient that you can find from points P and Q. So we equate that to the gradient from point P and Q. I'm going to take coordinates of point P and Q and work out the gradient. So delta y is P, yp, which is k plus 8, minus yq, which is k squared minus 2k. That's the y coordinate of Q. The x coordinate of P is -1. The x coordinate of Q is 3. And then you just rearrange that. So this is -4. I prefer to do cross multiply there. So -4 on the top left. And then you multiply. Let's simplify this first. So I have 2, and then in the brackets, that's minus k squared. And then minus -2. So this is plus 3k plus 8. Simplifying again, minus 2k squared plus 6k plus 16. That seems fine. And then I'm moving 2k to the left side, moving minus 6k on the left side, moving minus 16, I get minus 20. Dividing across by 2, I get what is required. Okay, that's part A, right? Part B, hence find an equation for C. Okay, so somehow we need to find k, right? So let's solve for k first. Well, I can see that it's just factorization there. Yeah, factorizing it, I get that. So k is 5 and -2, but we want k as a positive constant, so k is just 5. Now if k is 5, we can find the radius and point P and Q, right? Let me just shrink everything a little. Here we go. So P would then be point -1, k is 5, so 5 plus 8 is 13, and then Q would be at 3, k squared is, what's k again? 5, so 25 minus 10, which is 15, okay? 25 minus 10, 15, yeah. Okay, so P is the center. Now we need to find the radius to form a circle equation, yeah? So radius is just square root of doing the Pythagoras between 2 points there. So that's 15 minus 13 squared plus 3 minus -1 squared. So that's 2 squared is 4. 4 squared is 16, so that's root 20. So r squared is 20, right? Yeah, or I can just, hang on, do that in the first place. Okay, so that's 4 squared, hang on, 2 squared plus 4 squared. Yeah, I'm happy with that. Then we can now conclude that let me shrink a little more. Okay, here we go. We can now conclude that the circle equation would be x minus x, x minus h, which is -1, so it's a +1, plus y minus k, k is k plus 8, it's the y coordinate of P there, but k is 5, so that's -13 squared equals r squared, which is 20. So that's the circle equation, yeah? Number 10 is done. Number 11, we're at an hour. That should be fine. The prices of 2 precious metals are being monitored. The price per gram of metal A in pounds is modeled by that equation VA, where T is the number of months after monitoring began. The price per gram of metal B It's modeled as that. So we have two different equations for the two weights, where P is a positive constant and T is the number of months after monitoring began. Given that VB is equal to 2VA when T equals 0, find the value of P. Okay, so when T equals 0, we have VB to be P e to the, when T equals 0, so that is 0, right? And then 2VA, 2 times VA is the thing there, which is 100 plus 20 e to the power of 0. So e to the power of 0 is 1, so we have P here on the left side times 2 equals 2 times 100 plus 20, so that's 120, right? Yeah, I'm happy with that. So P is equal to 240. That's part A. Part B, when T equals big T, the rate of increase in the price per gram of the metal A was equal to the rate of decrease in the price per gram of metal B. Well, we talk about the rates here. So we should differentiate the VA and VB. Yeah? Okay. Yeah, okay. So I'm just going to do dVA by dt is equal to 100 goes away. So we have 20 times 0.04 times e to the power of 0.04 t, which is, what's that? 4 over 5, that's 0.8, right? Yeah. 4 over 100, 4, 5, yeah. E to the 0.04 t. And then dVB by dt for the same. Now we know P, which is 240, would be multiplied by minus 0.02 e to the minus 0.02 t. So that is minus 480, 4.8, minus 4.8 e to the minus 0.02 t. Yeah? Yeah, I'm happy with that. Now, it's given that at when time equals capital T, the rate in A is equal to the rate in B. Yeah, the rate of increase in A is equal to the rate of decrease in B. We got to take out the negative sign, because this is accounting for the sign already, because it says increase equal decrease. So we got to take out the sign. Okay, so we equate 0.8 e to the 0.04 t equals 4.8 e to the minus 0.02 t. We solve for this. Okay, so we cancel 0.8, we get 6 on this side. If we divide by both sides by this, yeah, we get 6 on the right side. So e to the power of 0.04 t over e to the power of minus 0.02 t, you can subtract the power. So this will be e to the power of 0.06 t using a law of indices equals 6. So I'm solving it. But let me shrink down again, because moving to another page will be a little harder for you guys to see, I guess. Okay, so we can solve for t giving to 1 decimal place. So we do 0.06 t equals ln 6 first, right? And then t will be ln 6 divided by 0.06. Okay, just going to use a calculator there. So ln 6 divided by 0.06. That's 29.9 to 1 decimal place. Yeah, there you go. Okay, so that is the big T. There. Okay, I'm done. Number 12. Okay, we have time, yeah. Figure 5 shows the plan view of the design for the swimming pool. The pool is modeled as a quarter of a circle joined to 2 equal-sized rectangles as shown. All right. A quarter circle has a radius x. The rectangles each have the length of x meters and the width of y meters. the total surface area of the swimming pool is 100 meters squared. Show that according to the model, the perimeter p meters of the swimming pool is given by that. Okay. Yeah, it's just a lot of x's and a lot of y's, and then you add the arc length of the quarter there. So it's a quarter of the perimeter of the quarter circle there, so which is 2 pi, and then r is x, right? That's just the arc length of the quarter right here. Yeah. And then we have how many y's? We have 1, 2, 3. So 1, 2, 3, 4 y's. And then how many x's? Just 1 and 2. So 2 x's there, right? Okay. And that would be the perimeters. It's given. Is it given? No, it's not given. So this is the perimeter first. We just leave it at this first. Hang on. That's part A. But we are given that the total surface area of the pool. So it's just everything there. So surface area 100 equals 2 of the rectangle. So 2 times xy. Yeah. And then 1 quarter circle. So plus 1 quarter of pi r squared. All right. Well, we don't have the y in the p equation there. So we need to make y the subject here. And the way to do that is, just to move 2xy here on one side, and I have 100 minus a quarter pi x squared, and then I would have y as a subject equals, if you divide across by 2x, you're going to get 50 over x here, right? Yeah, just do the math there. If you divide 2x into that term, the fraction will become 1 over 8 pi, and then 1x goes away, so you only have 1x there. That's it. We plug this into the perimeter equation. Yeah. 4y here and plus 2x. And if we simplify that, we should get the equation of the perimeter. So this is, what is it? Pi over 2x plus, I'm just expanding out, 200 over x minus pi over 2x here. That's nice. We can cancel. Plus 2x. So the pi over 2x cancel. And then we only have 2x plus 200 over x as a required. Yes. And then part B, use calculus to find the value of x for which p has a stationary value. Okay. Well, it's just dp by dx. We differentiate, yes. So that's going to give us, differentiating 2x, we get 2. Differentiating 200 over x, we get minus, right? 200 over x squared. Yeah, it's just x of minus 1, and then we pull down the minus 1, and then we subtract the power by 1. Okay, so we equate this to 0, right? Yeah. And then we need to prove that that is the minimum. Okay, so so we solve for x for this first. So 200 equals moving minus 200 over x squared to the other side. We get x squared equals 100. So x is plus minus 10. Well, it cannot be minus 10 here. So x can only be 10. And then to prove it as a minimum, we need to do a second derivative. So d squared p by dx squared is equal to, taking this and differentiate again, 2 goes away. Differentiating 200 over x squared, well, the minus 2 brought down, we get a plus 400, right? And then the power become 1 less, so that's power of 3 down here. All right, so I pull the minus 2 down, I get 400, multiplying the minus 200 there, and then power subtracted by 1. Now, if we plug 10 in there, the d squared p over dx squared equals 400 over 1,000, which is 0.4, which is greater than 0. So therefore, it is a minimum. So it is a minimum because we have proven that that is greater than 0, right? We can just write there. There. Yeah. So if it's greater than 0, it's a minimum. If it's less than 0, it's a maximum. If it's equal to 0, we call that an inflection point. Yeah. And this is, wait, hang on. Use calculus to find the x value. Oh, so this is part B. So x of x. Yeah, okay. So part C is here. Proved by further calculus. Yeah, already did. Part D. Access to the pool is by side AB shown in figure 5. By side AB, yeah, okay. It's like the entrance. Given that AB must be at least 1 meter, that is y must be at least 1 meter there. Yeah, because AB is y. Determine, according to the model, whether the swimming pool with the minimum perimeter would be suitable. With the minimum perimeter, it's just when x equals 10, okay? So minimum occurs at x equals 10, right? Because we just found it. Yeah. So if x equals 10, what is y? Well, we just have to take the equation between x and y. What did we get now? Okay, it's this guy here, right? So we can take this one. So that's 550 over x minus 1/8 pi x. Yeah, let me check. 50 over x minus 1/8 pi x. 50 over 10 minus 1/8 pi 10. So 5 minus whatever that is. Just going to use a calculator. So 5 minus 10 over 8 times pi. That is about 1.073 blah blah blah. Well, must be at least 1 meter, so that's fine. And that is greater than 1, so suitable. Yeah, that's it. Because it's at least, so greater is fine. And then number 13. Show that the equation that can be written as that. Well, seems like we can multiply across, no? Let me think a bit. Or maybe we can divide the whole thing by cos theta, right? So I just copy here. No, we don't. We shouldn't do that. Hang on. If we divide the whole thing by cos theta, although we get 10 and 10 on the other side, that would be, no, that won't be good. I'm just going to multiply out, actually. So multiply out, I get 7 sine squared minus 4 sine theta cos theta equals 4. Okay, that is weird now. Oh, I see something. Do I? Okay, what do we do? Well, seems like we need to change it to, okay. We can divide that by cos squared theta. So that would be 7 tan squared theta. So if we divide the 4 sine cos by cos squared, we're going to have a cos cancel cos, so we are left with cos down there. So this is minus 4 tan squared, because sine over cos is a tan. And then on this side, we have 4 over cos, right? So 4 over cos squared is 4 minus 4. 1 over cos is sec, so that's sec squared theta equals 0. Just moving it on the same side and divide by cos squared. Now we know that we know that sec squared theta is 1 plus tan squared theta, right? So I'm substituting that in. Minus 4, 1 plus tan squared theta equals 0, right? Well, if you simplify that, you should get what they want. So minus 4 tan squared theta here. And then wrapping up, yeah, we get 3 tan squared theta minus 4 tan theta minus 4 equals 0 as required. Yeah, that's part A done. Part B, hence solve for that. Right. Okay, so we are solving quadratically here. I would like to factorize by myself. So is it 4 and 1? Nope. Or 2 and 2? Yep, 2 and 2. So it's a minus here and a plus here. Right? If you check the middle term, you should get a minus 4tan. So we get two cases where tan theta equals minus 2 over 3, or tan theta equals 2 on the other one. Okay? Now for those of you who are familiar with the cast diagram method, this will be fine, right? Wait, we're solving for x, yeah? So x here. And x is in the normal period there, 0 to 360. So a negative tan would be what quadrant? Negative tan is this one and this one, right? And for this one is a positive tan, this one and this one. Okay, so just telling myself what to look for first, but I'm gonna shrink this whole thing again. Okay, so that I have more space. Right. Okay, so we need to solve for this, right? And minus 2 over 3. So we need a calculator. I'm just gonna find the principal angle first. So by that I mean it's in degree. All right. I'm just gonna do 2 over 3 first, not minus 2 over 3. So like that. So that's 33 point. So that's so the principal angle is 33.69007. But the angle we want here is the negative quadrants, which is the second and the fourth. So x equals, the second quadrant would be that plus, no, would be that minus 180 minus that, yeah? So that's 146. The answer is to one decimal place, 0.3. And the other one is just 360 minus that, right? Yeah, because we need to sweep towards the quadrant 4. Okay, so I'm done with that. Whoops, again. Okay, and then for the other one, if we do arctan 2, what do we get? We get 63.434 blah blah blah. So x equals, now we get, yeah, that one, because it's the principal angle, and 180 plus that, right? Yeah, so that's all our answers to one decimal places. This is part B. Okay, yeah, I think I'm happy with that. And then part C seems a little more, oh, it's just 1 mark. Hence, find the smallest solution of that equation. Okay. This is looking like we are putting x as 4 alpha, right? Yeah. So if you do consider x as 4 alpha, that you will see it's the same equation. Now, because the range of x is that, so the range of alpha would be, x equals 4 alpha. So the range of alpha should be x divided by that. Interesting. Hang on. Interesting. Okay. So let me put 4 alpha equals all the answer from x first. So I'm going to order them from smallest to largest, yeah. 63.4, 146.3, and then 243.4, and then 326.3, right? That's all there is. Hence, find the smallest solution for that. So we need to find, okay. Hang on. Okay, so this is when x is in that range. Let me think. This is a bit tricky. But alpha is equal to x over 4, right? So we can think about this as transformation. What you do there is shrinking. So you multiply, it's like instead of putting an x into the function there, you're putting a 4x instead. That means you are shrinking it down by 4 times. That means all the answer would be shrunk by 4 times. Yeah, that's why we have x over 4. But then, okay. So we want that. Okay. Let me just do this first. So if this is the range of alpha, we have to convert it to the range of x. So because alpha is x over 4, so if I multiply 4 across all sides, so that would be 2880. That's huge. This is x and 4,320. I just basically multiplied everything by 4. Okay? And why do I do this? Because I want the actual corresponding answer for x first. And you can do that by adding up, like how do you make this as close as possible to 2880 there? So you're going to be adding by 360. So how many 360? I don't know, maybe 8. Let's try that. 360 times 8. Oh, that's exactly that. Okay. So you're going to be adding that. If you add 8 times 2 pi, which is 8 times 360, like 8 cycles, you sweep 8 times, right? You're going to get to this guy, right? You're going to get to that guy. And we want the smallest solution. So x should be 2880 plus 63.4. Okay, so that means if I add that by 63.4, I get that. Yeah. So that means alpha, which is x over 4, yeah, would be that divided by 4. Answer divided by 4. 735.9, which is in the range. Now, I need to be safe here because 63.4 is actually rounded from 10 to there. So let me just clear everything. Yeah, so that's just that. And then if we do that divided by 4, yeah, we should get that 0.9. Yeah, that's right. Okay, so that's my alpha there, smallest. Okay, that's a bit complicated. I hope if I have time later, I'm going to come back and explain properly here. Okay, so number 14. almost the last question, guys, so I guess I'll have time for number 13 later. Prove using algebra that n squared plus 5n is even for all values of n being positive integer. So the capital N there is a positive integer or a natural number. Okay, and we know that natural numbers are either odd or even. Okay, so for the case where n is 2k, k is an integer or also a natural number there. This is n is even, yeah, so n equals 2k. So we have 2k squared plus 5 times 2k, yeah, and that is 4k squared plus 10k. We are proving that it is even, so we need to factorize 2 out, like that, and say that it is even because it's a multiple of 2, right? And for the case where n is odd, so we have n equals, let's use m plus 1, where m is also an integer, positive integer. So n squared plus 5n would be equal to 2m plus 1 squared plus 5 2m plus 1. So expanding that, I get 4m squared plus 4m plus 1 plus 10m plus 5. And then I have 4m squared plus 14m plus 6. Factorizing 2 out, I get 2m squared plus 17m plus 3. And that is again a multiple of 2. Hence, n is even here. Oh, why did I? Oh, hang on. Hence, it is even. Okay, so we have proved that for either case, they're both even. That means we can say that therefore n squared plus 5n is even for all n being natural number. Yeah, that's done. And that seems to be the end of the paper. Okay, let me just explain 13 properly, right? Again, so for number 13 here, because they want, assuming that the answer is right, because I haven't checked yet. Okay, you know what? Let's mark the paper first, all right? Yeah, if I'm correct, then I'll explain. So let's stop the timer. That's how long I spent, under the 2 hours limit there. And I think I'm happy with every question because I double checked every time I finish the question. So we're going to go from the first question and let's mark the paper. Okay, so here is the mark scheme for the 2024 syllabus AS Mathematics Pearson Edexcel 8MA0 paper. Okay, let's look at the first question. There you go. So I'm going to be using an orange color here. So that is right, that is right, that is right. Just going to be quick in marking it. 32 plus b here as required. 3 and what? I got that wrong. Wait. Oh no, that's not wrong. Sorry. I was just a bit surprised. Okay, and then yeah, that was C that I was looking at. So 3 and 12 here, and that is fine, right? K is 3 right here. Number 3, minus 6i plus 3j, correct? And then we get the length, and then what's that? We found the gradient. They use the gradient. I use Pythagorean here. So I think they should allow. Yeah, I use Pythagorean here. Okay, so I get the method mark, and that should be right because it was shown to be right. Yeah, and then this is 270, that's fine. Number 4, 10.5 as shown, 21.3, good. Number 5, yeah, nailed it for the graph thing. This is as required, so that should be right. -1 and 3, that's right. Number 6, a equals -5/8. K is that. That is that. Okay, correct. 7, A. Yep, that's correct there. B, the concentration 1 kilometer away. Yeah, I just wrote too much there actually. X equals 2 here. Substitute x minus 4 into the both equation and correct solution. Yeah, so that's how you verify. You don't solve, you verify, right? C, 108. Yeah, that's fine. Number 9, 2p for the first one, 1/2 p plus, where's my b? Yeah, 1/2 p plus q, p squared minus q squared over 4. I think you guys should look back into this question. Look into this question more if you don't understand. Yeah, but I think I explained everything there that I needed to. Okay, this one is fine. That's 20. That's good. K is 5. Yeah. 11. 240 there. 29.9. Yep. Cool. Yep. I got y first to be that, and then I showed, and then got x to be 10, and then I sub, so I get 0.4, which is greater than 0, so that's a minimum. And then the last part, that is greater than 1, so would be suitable. Nailed it. Number 13, I showed, and then I got the answer. See if I got all of them correct. So that is fine, that is fine, that is fine, that is fine. Good. C. Yep, I nailed it, so I'm correct. Okay, so the reason why we have to ramp up the x here by adding 8 cycles is because I need to make it into the corresponding range of x. So you see, because alpha is required to be in the range of 720 and 1080. And we know that x is 4 times alpha, it's just here. So if you do 4 times here, the range of x is from 2880 to 4320. Well, roughly, you need to add this by 8 cycles, which is 8 times 360 to get to this kind of range. But actually, when you do add that, you get this value instead, which is that. So if you want to find alpha back, you divide by 4 due to this equation, and then you get the actual answer, right? Make sure you understand this, right? Okay, so it's like working back and forth between x and alpha there. And I think I'm fine with that, yeah? Okay, hope you guys are too. And 14, the last one, I think I nailed it. That was easy. Yeah, that's fine. Proving, just pulling 2 out. So I got 100% raw score, guys. So no doubt that would be 100 UMS. And the feedback for the whole paper, I think, yeah, again, the tricky one would be, let me pull back the paper, yeah. Okay, so I think the tricky question is, let's start from number 1. Well, I gotta write there 100%. So how many marks here? I don't know, 100 marks. So 100 out of 100. Yeah, the tricky question, I think, is not that. That can be, yeah, I mean, if you don't know what to do with question CII here, right? Because that's transformation. try to make use of transformation. It's very useful if you know how it works, because you already got the roots for fx. So the roots for f a third x would be just to multiply by 3, because that's the way you transform in the x-axis. If you multiply by something, you divide by the same thing. So this is when you divide by 3, so you multiply by 3 to all the roots, right? So that's one of them. This one is fine. Well, the trapezium area. So the advice to this is to draw, right? Let me just go to my question 2 here, my answer. So you need to draw out the shape. Don't visualize in your head. I mean, I would like to do that, but it's too risky. So I don't want to take all the chances there. If there is a safer way, I do, right? So just to draw out. And you will see clearly it's a trapezium, because it doesn't tell you it is a trapezium. So you need to find that out by yourself, right? So that's number 3 there. Well, this one, yeah, I almost had a problem. I mean, I did, but then I figured it out. So that wasn't too bad. So this is sine and cosine rule, right? This one, well, you need to know how to use this given root, right? So I showed you already that it means that one of the root is 3x plus 2. I mean, it could have been x plus 2 over 3, but because we have 3 there, so I multiplied by 3, so I get 3x plus 2 instead of x plus 2 over 3. Yeah, so that is also the linear factor. You divide that to the polynomial, then you're going to get the other quadratic root, and then you work on the quadratic to solve for the other roots, right? That's the way to go. This one is fine, I guess. This one you got to be careful. Some students that I teach, they kind of they get confused how to use the 2 points. So it's not just a y. So in this case, if they trick you, rather than using a p, they use a y letter there. They're going to get confused. So if they instead say this is log 10 of y instead of a p, then you could be confused. So be careful. You just set the expression straight. This is just the formula of linear equation formation. So whatever on the y-axis, not the y, on the y-axis is log 10 of p. So you put that in, because this one x is still x, so that's fine. And the rest is just algebra. And now the tricky bit, I think, is b. Yeah. So you try to think how you get ab. When they ask for anything, you think how to substitute x so that p is ab. Now in this case, you sub x as 1. So there you go. Yeah. And you explain accordingly. So for number 8, I think, yeah, it's fine. Calculus and coordinates geometry. Oh, this one. This one is going to be a real deal here. Yeah, this one is not that easy. So you're going to have strong foundation in log properties here. Good basics, I mean. So yeah, I hope I explained everything clearly. So you need to maybe pay attention to how I got like question B and C there. So I would recommend you go and check, wind back and check again. Particularly the part C. Part C is very tricky, right? So I try to split them out. And what I did, the strategy was to split out the parts so that you see the rows of P and Q into the expression. Yeah, that's what I did. So I see P here, P here. Well, that is not exactly Q, but I know that Q can be derived into that. So log A of 5 is actually Q over 2 here. So that's what I did. Yeah. This one is classic for circle equation, so I hope that's fine, not too hard. 11. Yeah, 11. Yeah, you got to be careful when doing B, right? Because otherwise you're going to get weird answer. If you don't change the sign from negative to positive for the other one, like the model B, because B is decreasing, I bet you're going to get weird answer. Yeah, so you need to know that, right? Because it's an increase and a decrease. This one is fine. Yeah, just read the question carefully and form the equation and prove that. 13. Yeah, this one I got stuck a little at first, but then I figured it out that you just need the trig identity to just rearrange. And part C is the highlight here, and I think I already explained that, right? So just try check that out again if you don't understand. And 14 is classic, so whenever you see 14, you split into two cases. So when you see n being a big capital N like that, it's a natural number. It could be odd or even. So you split, and this is actually proved by exhaustion and also by algebra. It's algebra plus exhaustion, I would say. We exhaust in the way that all the cases for natural numbers would be odd or even numbers. So that's it. Yeah. So okay, guys, that was it for this whole paper. I hope that was all useful for all of you guys. And check out other videos. I have also walked through the mechanics and statistics on the same year here. So do check out the video, and I'll see you in there. Bye.